Okay, so what we have taken here is two wires of current I1 and I2 going through the X wire and Y wire, and this is what we are doing, a mutual force between two parallel infinite wires, and the distance between them is d. So we will derive the force which is acting between these two wires. So first we are going to do is, let us suppose there are two wires X and Y with distance d between them. Okay, so this is the basic part which we have to write in a answer. Sorry for the sound. So what I was saying, that we have to find the mutual force here, right? So we have to first find the, like, if there is an assumption in the standard derivation that we will put this Y wire in an external magnetic field of I1 or X wire's magnetic field. X wire's magnetic field B will already be present, and we will put I2 wires or Y wires into the magnetic field externally with no internal magnetic field present in itself, but because that will be a complicated case and that will be something else. So now then, so we will first find this X wire's magnetic field then, right? Because it's the external magnetic field for Y, and for X wire, that B is the magnetic field, the internal magnetic field of X. So first we will find that magnetic field. So magnetic field B due to X is, so we will find out the magnetic field here. Okay, so we will first take this X, this is Y, and this is Z, right? We will take this X, Y and Z. So first see, this distance we will take it as R vector. Okay, we will think of it as an R vector because this is force, so we have to treat it as like a force. This is R vector, and now if we know the formula, which is mu naught by 4 pi into 2 pi I d, right? This is the formula for a infinite long wire finding magnetic field at a point, right? So this is the formula, and now we can like easily cut that out. Sorry, it's not pi. The pi one is for a circular loop, right? It's 2I by 2, so we will just cut it out, and mu naught I by 2 pi d. I just memorize it like this because this is a whole thing, right? I don't want to cut it out, so that's it's easier to understand or memorize. Mu naught by 4 pi, because it has a whole value. So so this is our value, right? Putting this d here, it was R in the formula, and we are putting this d in the R formula. So this is the answer for B, and this is the magnetic field due to X here, right? Okay, perfect. Now this magnetic field B affects the Y wire, right? This is affecting, this is obvious, this is affecting the Y wire because there is also current flowing, right? So now we will find that out. And also this is a vector, so we will have to give a vector. See, we will have a trick, thumb where the current goes, the four fingers where the point we need to be, that where we need it, right? So this and this, so this comes around like this, right? This and this, it comes around like this. So the face of the palm, the face of the palm is the direction of the magnetic field, so it's coming up like this, upwards. So this is cross, cross, cross. And for this current like this, point here R, and the magnetic field inside. So this is point, point, point. This is inside. So this is outside and this is inside. So cross for outside, dot for inside. Okay. So this magnetic field for this, we have found it for X. So this is inside. So this is minus Z cap, right? Because this is, we have seen that this is the positive Z axis and this is the negative Z axis. So minus Z cap. Okay. Now we will now find that how this magnetic field of X affects magnetic field or the force on Y. So simply force on Y wire due to X, that will be F I. So see this I, this current will be of I2. Okay, so the force will be the force is I L cross B, right? So this is the force on Y wire due to X. So the force is due to X. Current passing through wire Y is I2, right? Here it is, it's I2. And the magnetic field which is produced by this X wire, sorry, that's B, this one, and the length of it is L. We take L, right? Or we can take Y cap or X cap, sorry, because like this is a unit vector, we are taking this as a unit vector. We are taking the simplest and most general solution possible, and X cap and B here. So that's I2 and that's mu naught I. Okay, so here it is I1, and here it is I1, that's 2 pi d, and yeah, all right, and that's minus. Okay, so that's X cap cross Z cap, and here it is a minus. So minus mu naught by 2 pi d I1 I2, and this is a minus. See, this is a unit vector, these two are unit vector, and these are perpendicular, X cap and Z cap, these are perpendicular, so this will cut out, right? And this is also not X cap, I'm really sorry, this is not X cap, this is Y cap, right? This is Y cap, see, so we will take it as Y cap here. This is Y cap, this is Y cap. So Y cap and Z cap, these are perpendicular, right? So sine 90 is 1, so it will cut out, and this is our formula for force. But we are measuring force per unit length, which is mu naught by 2 pi d I1 I2. This is the one, this is the one, right? And also I just forgot to mention that when we are doing this Y cap, this also is including, like, see, Y vector is equals to Y cap, right? Because Y is the magnitude and this is the direction. So when we are putting Y cap, we are already taking out the magnitude part. So we can take out the magnitude part here and then here, and then this length is Y because it was here and then it comes to this side. So this is F by L or F by Y equals to mu naught I1 I2 by 2 pi d. And if you are asking about this minus, so this minus varies because if this two, as you can clearly see, if these two are in the same direction, then they will attract each other, and that causes this minus sign, and if they are opposite direction, then they will create the positive sign. Okay, if they're in opposite direction, the current I1 and I2 are in opposite direction, then they will do this, result in this one. And if they are in the same direction, then they will result in this one. Okay, so thanks for watching.